Hello and welcome to PPK post-processing with EZSurv. The first thing I'm going to want to do is type in EZSurv in our program search window. This is going to run through our program software updates, make sure that those all run properly, and we get a nice blank project manager screen here. So the very first thing I'm going to do before I bring any data in is go to Edit, Geoid, and we are going to want to use a geoid model. There's two different instances of which geoid models we can use. I'm going to go through the standard generic model first, and at the end of the video I'll show you how to use a more localized projection and datum and geoidal surface for around West Lafayette, Indiana. So first we're going to go to World, Global, and EGM 96, the 2015 edition. That's going to be our geoid model that we're going to use. We'll hit OK. Then we'll go to Tools, Mapping System Selector, and this is going to pull up our coordinate system that we are going to be using. And since we used WGS84 for our geoid model, we're also going to use that for our mapping system. So again, I'll go to World, Global, Geographic, WGS84, and Geo, WGS84, and hit OK. And now that we have our geoid and mapping system selected, we're going to go to our data folder for our project. We'll go to Collection, PPK Data, and we'll have a bin file, a text document, a configuration snapshot, which is the PPK configuration settings that we used for this flight, and a geotags tool application. For this though, we're going to want the bin file. We're just going to bring that in. So now this will load our flight and PPK data and start pulling those files from the PPK that were gathered during the flight. Alright, so once our file is uploaded, we can go over here to Display Plan View, and we'll actually see our flight plan. And this looks appropriate for the flight that we did, so we know that our GPS positions from the PPK look good. We can go back to Display the Project Manager. Now I'm going to want to click on our bin file that we brought in here, and I'll go up to this button here, and it says Start Automatic Processing. We're going to want to click that. Now what this is going to do is it's going to start pulling our RINEX data and identifying our CORS network station that is nearest to the flight area. In this case it was INWL, and so that's going to take a moment, and I'm going to speed up the video, but when we come back we will look at our initial processing results. Alright, so here we have our initial processing results. You can see that our mapping system is in fact WGS84. Projection template is geographic. We have WGS84 for our datum, and EGM 96 2015 for our geoid model. Our base station is INWL. It has two fixed constellations, meaning satellite networks, which are GPS and GLONASS. And then we're also going to look at the distance. Our rover log was from the CORS station was 8.1 kilometers. That's pretty good. Here we'll see the total number of fixed, floating, or failed epochs. Here we can see we have 99.7% of those are fixed, so that looks pretty good. And now we're going to want to go into Tools, Events Interpolator, and we're going to select our events file. So go into our data folder, collection, PPK, and this text document is the position information of all of the image captures that was recorded by the PPK. So we'll bring that in. and we will configure our events file format. For the delimiter, since it's a CSV file, we will say that it's a comma. Number of lines to skip at the beginning of the file, that just means how many header files are there. We have 2, so we'll hit 2 and then check use line 2 as header. Now this looks right, so we'll hit next, and then for the time columns we'll select GPS time of week and GPS second, and we'll hit save. Now we'll also make sure that we do not update the position within picture EXIF. If that is selected, please unselect that and just check that it is not selected before you move on. Then we'll go to our antenna offset, and these should be respectively 0.025, 0.082, and 0.387 for the camera versus PPK offset. Then for our output file, we'll check that we want a CSV format and that we have the following file columns in order as picture, latitude, longitude, height, and orthometric mean sea level. Now this is important that you use this one versus height and ellipsoid because we're using an orthometric surface. So make sure you have that. Also notice that when you click on one of these, if it is selected, it will unselect it. If it is not selected and you click on it, it will select it. So just make sure that these are checked and that they are in the correct order. After height orthometric, we will have our standard deviation for latitude, standard deviation for longitude, and standard deviation for height. Once all of these are in a row, then we will hit OK, and we will go to our image folder for our data folder, and assuming we have a 1-to-1 match of 170 events and 107 pictures, we will have our output files generated. So now we'll go to Open Output Folder, and you can see here we have 2 Excel documents. The first one is the events header, and we'll open that up first. And this will tell us about our datum and coordinate system that our corrections were performed in. Again, we're just checking this to make sure that there's consistency throughout the process. So here we can see that it is a course station that was used, INWL specifically. And remember that it was 8.1 kilometers from our flight area. Our datum is WGS84. We have our events file that was used here. This is the file path for it. That looks right. Our geoid model is the EGM96 2015 edition. Mapping system is GeoWGS84, and it is a metric measurement system. Our picture folder was this file path, and our rover file was this file path. So those all look good. So we'll go ahead and save that and close out. Then we're going to open our events file, and this is all of the corrected geotags for each image in our data set. So here we can see that we have the picture number, its latitudinal, longitudinal, and height position above mean sea level. And we also have our standard deviation for latitude, longitude, and height. The first thing we're going to want to do is with this is hit Control-Shift equals, and that will give you 3 new columns. Then we're going to do omega, phi, and kappa. And this is putting it into a Pix4D readable format. And I'm just going to put zeros in all those columns all the way down. Alright, check that that looks good. And you also want to make note of these heights, latitude, and longitudes, and just make sure that they're within reasonable range. 344 meters above mean sea level seems reasonable, so we're going to assume that that's right. We'll hit save and close out of that. And now this is what we will use for our geolocation in Pix4D. And now that we have that, we can hit OK, close out of EZSurv without saving because we already have our output folders. Okay, for part 2 of this EZSurv PPK post-processing video, I'm going to show you the second geoid model and projected coordinate system option for using a localized data set where high precision is required in the West Lafayette, Indiana area. So much like the other video, the first thing I'm going to do after opening EZSurv before inputting any data is go to Edit, Geoid. We're going to select Use a Geoid Model. And instead of this time using the EGM96 model, we're going to go down to America, United States of America, Geoid 12B, and Conus Grid number 3. This is going to be our local geoid model. We'll hit OK. We'll go to Tools, Mapping System Selector, and instead of using the WGS84 mapping system, this time we are going to use America, United States of America, UTM, North American Datum 83, 2011 edition, and we're going to use the 16 North section of that. We'll hit OK. And then proceed to add the bin file like you would. Bring that in, and the rest of the processing is exactly the same, but now instead of using the WGS84 geoid model and WGS84 geographic projection, we are instead using the geoid 12B Conus Grid number 3 geoid model with a North American Datum 2011 Universal Transverse Mercator Zone 16 North projection. Hopefully this is helpful. Thanks for watching.